Okay, so let's look at some graphs and figure out the equation. Now the nice thing is that we actually know the vertex is here. So a good form to know is y equals a x minus b squared plus c. This is the vertex form. It's very useful. Notice how this graph is from the vertex goes one to the right, one up. And this follows the standard quadratic. When you have a regular parabola, our standard y equals x squared. When we go one unit to the right, when x is 1, 1 squared happens to be 1. So 1 right, 1 up is your standard parabola, where the a value is simply 1. It's not stretched whatsoever. So this particular graph is not very surprising. We're going to say y is equals to, the a value is 1. This is shifted 2 to the right. We have x minus 2 squared. And the parabola goes down 1, 2 units, minus 2. So this is the first equation. So for b, again, we have a vertex here, and we go 1 right, 1 up. So this is your standard parabola, simply shifted 2 units down. So this is y is equals to x squared minus 2, 2 units down. Now for c, we have a nice parabola here and it's upside down, so it has to be a negative a value. But notice how when we go 1 unit to the right, the graph is not going 1 unit down, so we don't actually quite know the a value. So rather than giving up and crying, we really should be substituting x and y. Plug in x and y. And the point that we do know that's on the graph, it's easy to see on the intercepts. What I see here is 0, negative 3 is a point. So look around everywhere. Look on the intercepts. Look for where the graph actually hits a nice crosshair. We could have also chosen this point here, 6, negative 3. But let's write it here. Y is equals to a. The graph is 3 to the right, which is x minus 3 squared. And it happens to be right on the intercept, so we don't have to bother writing plus 0. So again, we have the vertex form, and we just have to substitute x and y for a known point on the graph. This is x is 0, and y here happens to be negative 3. And the rest is simply algebra. So what we have is negative 3 squared is 9. So I'm going to erase this a here, and I'm going to write 9a. Now we just divide both sides by 9. We get a is equals to negative 3 over 9, which is the same thing as negative 1 over 3. So we actually solved it. The equation now is negative 1/3 x minus 3 squared. And we have the actual equation of the parabola. Okay, so we're looking at D. Whenever the graph crosses through the intercepts very cleanly like this, we know that the root here is 1, and we know that the root here is negative 2. So right away, we know the factors. Now, we're not quite so sure about the a value, so let's leave the a there just to be safe. But the factors are 1 and negative 2. Sorry, the roots are 1 and negative 2, which makes the factors the opposite, x minus 1, and this becomes x plus 2. So the factors and the roots, or the x-intercepts, have a connection, but sometimes you have to think opposite. So how do we find the a value? You have to look for a point. We're fortunate that this one here is very clear on the intercepts. This is 0, 4, and we're going to substitute x equals 0 here and here, and y equals 4 over here. So we have 4 equals a, 0 minus 1, 0 plus 2. So 4 is equals to, this is negative 1 times 2 is negative 2. So we have negative 2a. Divide both sides by negative 2. We get 4 divided by negative 2, which happens to be negative 2. So we have the equation y equals negative 2 x minus 1 x plus 2. And this is a legitimate equation. If you really want to expand it out, you could. So let's do it. Negative 2 bracket, just FOIL it out. This is x squared. 2x minus x is plus x. And last, negative 1 times 2 is negative 2. And we're just going to use distribution here. So negative 2x squared minus 2x plus 4 is a valid equation. And of course, if you really wanted to, you could complete the square. In fact, if you look very carefully, the halfway point between these three squares is the vertex. So we could have also used some other approach to get this equation by attacking the vertex form, but this here is a legitimate technique.